majority of you in the room probably know Alan because he does so many things for Renaissance. And so, Alan.
Good afternoon. Can you hear me? Yes. All right. Well, I'm going to introduce Tom, and with the distinct honor and privilege that I do that. He's one of our newer Renaissance members and one of our more distinguished Renaissance members. For those of you that have not heard him lecture, you're in for a treat. And only for Tom or someone of his stature, which there are few, if we ever think about changing our format from 1 to 2 hours. That tells you something. Tom is a marine biologist who's been conducting research around the globe for the past 40 years. Growing up in Connecticut, Tom began his environmental career in the 1970s, studying the impacts of thermal pollution from a power plant on plankton populations in Long Island Sound. Since then, he has studied environmental impacts from contaminants such as DDT, oil spills, mercury bioaccumulation, and radioactive fallout. For the past 20 of those years, he has been focusing on the greatest threat to human civilization, climate change. Tom earned his PhD from the University of Washington in Seattle and has had 3 diverse careers. First, conducting research and teaching at UC Davis for 20 years. Second, with the U.S. Fish and Wildlife Service in Sacramento as director of their Environmental Contaminants Division. And third, with the U.S. Geological Survey, also in Sacramento, as their lead scientist and research manager. Tom also spent 7 years as the Western Regional Director of the National Institute for Global Environmental Change for the Department of Energy. Before joining UC Davis, he also spent 3 years at a marine laboratory in the U.S. Virgin Islands, teaching and conducting research on coral reefs, as well as diving up to 12,000 feet in depth in a research submarine to study sea urchins in the deep sea. His work in the Caribbean led him to co-author a book with Jacques Cousteau in 1984 called Marine Life in the Caribbean, which is just one of over 150 of his scientific publications. Marine Life of the Caribbean is out of print. Perhaps you can get one on A-Books. I brought in one that he kindly gave to me, co-authored with James Cribb, Jacques Cousteau. Tom and his wife Cindy have been married for 37 years and have 2 sons. Andy, who earned his master's degree in environmental management and works for Apple, and Zach, who recently completed his environmental engineering degree from Cal Poly at San Luis Obispo. Cindy taught environmental science at Maryland High School for over 30 years and was awarded in 1910 by the National Science Teachers Association in 2010. The prestigious National Environmental Science Teacher of the Year Award, 9 years ago. Tom and Cindy are also Renaissance members. Tom and his colleague Dana Nucitelli will be here this afternoon, co-taught an excellent 12-week Renaissance Saturday morning seminar on climate change last fall, which attracted over 100 participants. Those lectures are available on his website, tomsakonic.net. And as one of those 100 attendees, I urge each of you to watch those lectures. They're stellar. We're extremely fortunate to have Tom present today in the Renaissance Society first ever 2-hour format to update us on the latest information on the most critical environmental crisis of our era, climate change. Please give Tom a hearty welcome, both for being with us today and for all that he does for our climate.
Thank you, Alan, for that very kind introduction. But I guess that takes care of the first hour of my lecture. But seriously, I'm very honored to be here and so impressed to see all of you dedicated lifelong learners. It's amazing to me. And today to try a new format. So I appreciate that as well. Today I'd like to speak to you about our extreme and unpredictable events that are becoming more and more common, why it's happening, how we can address these catastrophic events. And I'm not going to sugarcoat it, and I'm not going to exaggerate. I'm just going to give you the pure facts and hopefully update you on the reality of our current situation. And I will be asking you to help in solving this crisis. So today we're going to try to cover what the cause is for global warming and climate change. How serious is it? What are the local to global impacts? And then, of course, at the break, we're going to have a quiz. Then, after the break, we're going to be doing the important part of telling you how amazing new technological and political solutions are that we're developing. And what's the timing? How long do we have to fix this? How can each of us make a difference? And at the end, of course, we always have a final exam. All right? So we want to make sure that we're all understanding what's going to happen. I am sorry about that thing at the top. So just so that we understand, and nobody is not understanding this, the Earth is now experiencing extreme temperature fluctuations, extreme snowpack fluctuations, extreme storm winds, tornadoes, hurricanes, floods, droughts, fires. We know a lot about fires here. Mudslides after the fires, rapid sea level rise, increasing El Nino events, increasing extinction events for species, extreme seasonality changes, rapidly rising ocean acidification. And this is happening every day. Turn on whatever news you watch or listen to, a newspaper, or radio, or television, Reddit, magazine, doesn't matter. These things are happening every single day. And they're becoming more common. So this is just from yesterday. We have this big polar plunge coming down from the Arctic. More than 100 record lows were registered yesterday, and over 200 million people were dealing with the record low temperatures in danger. And here's another one. 2 days ago, Venice is in a state of emergency. Probably many of you saw that. These are tourists trying to find their way to St. Mark's Square, walking on this little platform. Some of them made it, some of them didn't. But I also want to say that there's only 6 times in the last 1,200 years that they have had that much flooding in Venice. Venice is prone to flooding anyway, but it's much, much worse now. And lastly, about Venice, this is the Veneto Regional Council's office. This here is water inside their regional council's office, right after rejecting measures to combat climate change that day. So there you go. Okay, let's do a reality check. Climate change is the greatest existential threat to human civilization and to life on Earth for all species. There's no question about that. And in some senses, it's very simple. We need to develop non-carbon-based alternative energy sources. And on the other hand, it's extremely complex. We need to deal with the laws of physics, chemistry, biology, changing our technology, sociological issues, lifestyle changes, transitions, lots of money, and unfortunately, politics. Climate change is a human health issue. It's a societal instability issue. It's a national security issue. It's an economic security issue, an environmental impacts issue, and again, unfortunately, a political issue. However, there's tremendous economic opportunities with this. We should be able to, and we should be doing now, development of new solar energy, wind, hydroelectric, grid-scale batteries, automobiles, ships, home retrofits, energy-efficient products. We could be doing all this. We could be ramping up our economy, probably with another 20 million jobs just right off the bat. But I want everybody to be on the same page in terms of how we understand what's going on and what the critical issues and elements are. So we're talking about the greenhouse effect. I think we can see that up there. First, we have the natural greenhouse effect, where the sun beats down on the Earth. Some of that heat is absorbed, some of it's reflected back out into space. But we have these greenhouse gases, carbon dioxide, nitrous oxide, and methane. These are heat-trapping gases, and basically without without these gases, without these heat-trapping gases, the Earth would be at 0 degrees Celsius. The oceans would freeze over, and all life on Earth would stop. So we need greenhouse effect. However, we have a human-enhanced greenhouse effect, and it's basically the same. The sun beats down on the Earth. Some of that's reflected back out to space, and some of it is contained in the Earth's atmosphere. Only that because we've been adding a lot of CO2 and methane and nitrous oxide, that they have accumulated more heat as well. So the Earth is warming up dramatically. So what is carbon dioxide? Carbon dioxide is the biggest issue that we're trying to deal with. We have several other greenhouse gases, but I'm going to focus primarily on carbon dioxide today. So carbon dioxide is a molecule. It's composed of 1 atom of carbon, 2 atoms of oxygen. You can't smell it, see it, feel it, taste it. It's there. It does have mass. So where is it coming from? Basically, it's also 1 in 2,500 molecules of air. So it's very rare, but it's very powerful at trapping heat. Next, where's it coming from? It's coming from the burning of fossil fuels, from power plants, planes, trains, and automobiles, and other combustion, all other combustion, and some from cement production. Where is it going? Where is it going? Well, carbon dioxide is taken up by trees, by plants in the leaves, through a process of photosynthesis. How many people can tell me the formula for photosynthesis? All you have to do is read it off the screen. It's right there. So we have a couple of molecules here, 6 molecules of carbon dioxide plus 6 molecules of water. In the presence of sunlight, produces this little bitty here. This is a sugar or carbohydrates plus, the most important part, oxygen. This is where we get all of our oxygen on the Earth, is from plants. And so let's look more into that. So scientists have known about the heat-trapping gases for a really long time. They started understanding this in the 1800s, and I don't have time to go over all of these guys and their contributions, but this little guy in the middle, Svante Arrhenius, first developed a model by hand, pencil and paper. Took him 2 years, and it was amazing. It was pretty accurate. He won a Nobel Prize, not for that, but for something else in chemistry. But after 2 years, I've heard that his wife left him. So I don't know what it is about us scientists, but that's sometimes what happens. Don't worry, Cindy, wherever you are. So I'm going to focus on another fellow down here, Charles Keeling. And Charles Keeling was the first guy to really start measuring carbon dioxide in the atmosphere. He was locating himself at Mauna Loa Observatory in Hawaii at 11,000 feet, and he started measuring in 1958, and he measured and that program is still going on today. You notice that this little red line is going up and down and up and down and up and down and up and down and up and down, and up, all the way up. And the blue line is an average of this concentration of carbon dioxide in the atmosphere as we go towards the present. So it's getting higher and higher and higher. And right now, that's reached about 413, 415 parts per million, way up here. That doesn't mean anything per se, it's just a number, but it means that we're getting higher and higher all the time. So why is it going up and down? Well, it's going up and down because as we approach the spring, leaves start coming out on the trees, and the concentration of carbon dioxide goes down. Why? Because the leaves are sucking out the carbon dioxide out of the atmosphere, and they literally decrease the concentration in the atmosphere. Come to the fall, what happens in the fall? Leaves fall, right? Very good. I knew you had it. So then the concentration starts going up again until the next spring when it goes down, and that's what you see, up and down all the time. So here's that graph, the Keeling curve right here, 1958. Let's go back another 1,000 years. So about 1,000 years ago, the concentration of carbon dioxide was about 280 parts per million. And it kind of bumped along there, pretty much the same, until the time that we had the Industrial Revolution. Sometime between 1750 and 1800, we started burning fossil fuels, coal, oil, gas, and those heat-trapping gases that were produced from there, the CO2 and some methane, started to trap that heat, and the concentration of carbon dioxide started going up and up and up in exponential fashion, sometimes called the hockey stick, because it kind of maybe looks like a hockey stick, but it's going exponential, faster and faster all the time. So the global community, all the countries of the world, have been emitting about 100 million tons of carbon dioxide every day into the Earth's atmosphere, which leads to about 40 billion tons per year. That's a lot of carbon dioxide, especially since it doesn't have much mass. So that's one of our main problems. So fossil fuel emissions from burning all that stuff account for about 94% of the total carbon dioxide emissions from human sources as follows. Coal contributes about 42% of our carbon dioxide, oil 33%, natural gas 19%, and cement plants is too complicated to talk about, but another 6%. And changes in land use, when you deforest an area like the Amazon, that in a backwards kind of way, it also decreases, it increases the carbon dioxide in the atmosphere. So, our country was built on coal and oil. So here's a couple of pictures of Kentucky coal mine. These guys, we owe a great deal to them. This is Long Beach in the 1930s. I'm not sure how many people were either around or know what that looks like, but it was pretty amazing change between the 1930s and the present. So oil and coal were being produced and were being burned, and really right now coal is going down. So the employment of coal over time is dropped tremendously. Coal use is declining as well. In the United States, this is what it looks like. So why is it going down? Well, it's going down because of production efficiency in coal mining, and also because there's a lower cost for natural gas as opposed to coal. There's also alternative renewable energy sources, and through regulations to protect human health. So that's why coal is declining. Also, California, interestingly, has 10 times more jobs, about 500,000 jobs in the alternative energy field than the entire U.S. has in coal jobs, only about 50,000. We're making progress, and hopefully we will continue to make that progress if, well, never mind. So who's producing this by country? Who's producing this? These are the annual carbon dioxide emissions by country. China is producing the most, about 27%. And up until 2005, the United States was actually the leader in producing carbon dioxide, but China passed us out at that time, and you'll notice that China's proportion is getting bigger and bigger as they're going towards the present time. And one of the reasons is that China is buying all of our coal, and they're burning it in China, but then that goes into the atmosphere and circulates around the Earth. So unfortunately, China is not they're not contributing to reducing carbon dioxide, they're contributing to increasing it. We'll talk more about China later. So the United States is actually around 14 or 15% of the global contribution to carbon dioxide, and we need to change that. Here's Bessie, the cow. And Bessie is one of those creatures that produces methane. I think you guys probably know where it's coming from. Actually, it's interesting that, so let's take a look at what's happening. Methane is actually about 20 to 80 times stronger than carbon dioxide as a greenhouse gas. The thing is that carbon dioxide stays in the atmosphere a long time, 500 to 1,000 years, whereas methane stays in the atmosphere only about 12 years. So in the long term, carbon dioxide is much, much worse in terms of putting into the atmosphere. So where is this stuff happening? So each one of these animals produces CO2 just from breathing, respiration, but they also produce methane. And interestingly, Bessie is not putting out methane the most out of this end. She's doing it out of this end. Most, like 95% of the methane that's coming from cows is not on that end, it's on the front end. But there's also other things that come out of the back end that do produce methane, and we have to deal with that. So what's interesting is that there's about 1.5 billion cattle on the earth, and they produce about 25 to 100 gallons of methane per cow per day, which is about 28% of all the methane emissions, which equates to about 3% of all of our total greenhouse gases. So cows are really up there in producing the bugaboo that we have now. Okay, I'm only be able to give you a few examples of impacts because we all know what's happening around us, and I don't need to repeat them, but I did want to say this fellow here, James Hansen, who was the director of space studies at NASA in 1988, testified before Congress. This is a New York Times article about him. And having worked on this himself, he has projected a model that basically tells us how warm the Earth is going to get by continuing to produce CO2 into the atmosphere. We're going to talk a little bit more about James Hansen later, but just recognize that 1988 is a special year. So around 1988, the United Nations Intergovernmental Panel on Climate Change was formed, the IPCC, with thousands of scientists around the world collecting data and starting to publish. 1990 was the first publication, what they call assessment reports. About every 5 to 7 years, they produce another report. And many other types of reports, like from the U.S. Global Change Research Program, which is a program I worked in for a while, they are on it. There's no question about the veracity of what's happening. And I'll just flip through a few reports. It's not that they haven't been working hard. These things are coming out all the time. And I could go here the rest of the day producing the reports that they give us. Thousands and thousands of both assessment reports, climate assessment reports, as well as scientific publications. So the science is there, science is clear, there's no question about it. And 97% of the scientists who are working on global warming agree that not only is it happening, but it's also human caused. And I think now that things have gone further, we're looking at 99% of those scientists. So there are deniers out there. There's one that we know about a couple of years ago. And there's conspiracy theories. There's about 200 conspiracy theories out there. But this particular website, skepticalscience.com, is a good place to go. If you hear a particular conspiracy theory, go to this site, go to the search bar, put whatever information or conspiracy theory you have, like it's the sun, stupid, put it in there. And they'll give you 3 explanations. One's a very simple one, very easy to understand. The second one is going to be an intermediate level of complexity. And the third one will be a scientific explanation of what's going on. So it's a great site. Visit it. Dana used to contribute to that on a regular basis. Let's talk about temperature. So here's a plot from January through December of each year. This white line is basically the average of the temperature of the Earth at that time. This scale here is increasing temperature, how much the Earth is increasing in temperature. And you can see this, each one of those purple lines is a different year. So that you can see as you go towards the present time, those lines are pretty thick, and then they start separating and separating further. And now, 2019, what's happening? Why is that so? Why are they separating? What do you get from that?
More carbon dioxide.
Yep, and it's going faster and faster over time. So now, the last 5 years are also the hottest years ever. And so you don't see any of these hot years down here. The last 5 years, 16, 17, 15, 16, 17, 18, 19, are the hottest years ever. And we're continuing to break those records. So let's take a look at what's happening with CO2. So this is carbon dioxide from 1880, increasing, and with that increase, because they're heat-trapping gases, the temperature is variable, but it's continuing to go up and up and up and up, back to where we are now, about 415 parts per million. The last time that carbon dioxide was 415 parts per million in the atmosphere, humans weren't even around. That was 800,000 to 20 million years ago. Global temperatures were substantially higher. There was almost no ice on the planet, and sea level was about 100 foot higher than it is now. Be careful. So this is basically what's happening. I mean, this is our oceans. We're heating up the oceans. A lot of that is evaporating into the atmosphere. This is the temperature track for the ocean temperatures, going up and up, just like the atmospheric temperatures. And where is it going? Where's all this heat going? Well, basically it's going to the upper ocean and the deep ocean. 92% of all the heat produced is in the ocean. A little bit in the ice, a little bit in the land, and just a little smidgen down here in the air. But primarily, the oceans are absorbing over 90% of all the heat that's been coming into the Earth. And we're breaking heat records all the time. Focusing on the United States first, like 2017, 16, 17, 18, 19. Here's Tucson, broken record. Las Vegas, 117. Phoenix, 119. And just in July of this year, 229 million people out of the 329 people that we have in the United States were under a dangerous heat warning. And we're not alone. This is happening all over the globe. On this particular day, on July 25th, Paris was 108.7. Wouldn't want to be on the Eiffel Tower then. Okay, with the heat comes drought. Everything's drying out, and this is a plot from 1890 to 2018, and this level here is a mild drought, and then moderate drought, and severe drought, and extreme drought. Excuse me. So you can see as we're coming towards 2018, the droughts are getting more and more severe. And we can see that if look at the lower 48, the western region is the one that's suffering. The darker the color, the more the drought, the worst effects of the drought. You can go to this U.S. drought monitor any year, any time, and you can see where the droughts are. We're starting to go into another drought right now, if you haven't noticed. Let's take a closer look at California. So this is what California looked like from over here. And they have the different categories: severe, extreme, and exceptional. This last one, this kind of brown one, they actually had to create a new color to represent exceptional drought, which kind of gives you the impression it's getting worse. And then on July 1st, 2019, Guadalajara, Mexico got 5 feet of ice. This is bizarre. Why is that happening? James Inhofe went into Congress one day with a snowball and said, "See, there's no global warming. I've got a snowball in my hand." Well, the problem is he went in February when you do have snowballs, so I don't know. But the reason why this is happening is because the Arctic, the North Pole area, is heating up the fastest. And when that happens, it starts to disrupt the wind patterns and the jet stream. And here's what that polar vortex looks like. We've heard about polar vortex on the weather station. Normally this jet stream circles the North Pole, the polar vortex up here, and when it gets disrupted, there's a high pressure system comes in, that entire jet stream plunges down into the lower 48, right here. And that's why we're getting cold weather in odd times of the year. Right now we're getting really cold weather because we have another polar vortex or a polar plunge coming down into the lower 48. All the, breaking records left and right. So let's look at the North Pole. So this is the Northwest Passage. This is the northern sea ice in the Arctic in 1984. And if you can see through the haze there, you can see what happens in 2016. It's the same time each year, and there's a lot of that sea ice that's missing. And here you can see a plot of what's happening with sea ice declining in the Arctic. Now here's Greenland right here. Greenland is in trouble too. The ice sheets are falling off really fast. This was the mass in 2002, and this is the mass in 2016, way down here. Interestingly, in July of this year, the melting Greenland ice sheet poured 197 billion tons of water into the North Atlantic in 1 month, in July alone. So these are just examples of what's happening out there. Fire. We get great sunsets from fires. I love them. 2018 had $26 billion in damages. I don't need to tell you guys much about fires in California, but the Napa-Sonoma fires, you probably remember those in October of 17. Burned 170,000 acres, $17 billion loss, and 42 deaths. And the Camp Fire in Paradise in November of 18 and ran into January of this year. This is a NASA satellite shot of that Paradise Fire. $16.5 billion lost, 240 square miles of area burned, and the highest number of deaths from fire in California, 86. And now that's what it looks like. People are going back. I don't know that I have the courage to do that, but people are going back and they're rebuilding right now. We know some people who are doing that. Here you can see large wildfires over 1,000 acres per year are on the increase, 1970 to 2016, and they're going up and up average. This is the average line right here, but they're increasing over time. And California's fire season had increased by 75 days, earlier and later. So it may be all year long soon. So how much is due to climate change? So I think the calculations have been made back here in 1985 or 1990. There was hardly much contribution to climate change, but the calculations have been made, and now we're looking like 50% of the fires are due to the contributions from climate change. So it's not a yes or no, it's not a due to climate change or not, it's a statistical average over time that's getting worse and worse. Again, we're not alone in the United States and California. Brazil, just this year, had 74,000 fires. And that's not good in terms of burning the forest, because the forest is taking up carbon dioxide, or it was before it burned. But also, it's also producing 20% of the oxygen on the earth. So we burn off the Amazon rainforest, and we're going to be really not very happy. Okay, storm. Okay, we get into flooding. This year, again, the Arkansas, Missouri, and Mississippi rivers had the worst flooding in their history over a century ago. And we have these extreme rain events. This is called a rain bomb. This one was in Kauai in 2015. Record fall, 15 inches of rain in 24 hours. I would not want to be in one of those. Also in Phoenix, same thing, 2017, another rain bomb. And we now have bomb cyclones, or cyclogenesis, and that's defined by a drop in the barometric pressure of 24 millibars over 24 hours. Huge, enormous winds were picked up here and just destroying everything in their sites. This is Texas and Oklahoma and Nebraska. And looking at hurricanes, there doesn't seem to be an increase in the number of hurricanes yet that we can detect. However, hurricanes are more powerful now. We have a lot more Category 4 and Category 5 hurricanes. This was Harvey in 17, Category 5. Michael, Category 5. Irma, Category 5. Maria, Category 5. A couple 4s in there. And so what's happening, just as an example, the Dorian hurricane was just a couple months ago. Pretty much blew out Bahamas. But it's a Category 5. Has winds of 185 miles an hour. Gusts at 220 miles an hour, and moving west at a whopping 1 mile an hour. So when the hurricane sits on top of a place for 24 hours, and it just pounds it with rain and winds and destroys much of what's there. Now, the categories of hurricanes have a certain mile per hour designations, and we only have 5 categories. If there was a 6th category, this hurricane, Dorian, would have been a Category 6. So we're increasing all the time. Tornadoes, same thing. I don't need to belabor this, but this is what we're experiencing, increasing tornadoes, over 1,000 of them reported this year. And only in America do we accept weather predictions from a rodent, but deny climate change evidence from scientists. Sad but true. All right, sea level rise. Let's talk about sea level rise. There's a lot of factors that go into what controls sea level rise, and we don't have time to go into all of them today, but I'll just summarize. About 50% of the sea level rise is from the melting of glaciers and ice caps. About another 50% from seawater expansion. You wouldn't think that seawater would expand that much, but it really does, and it raises the level of the ocean. So another 50% is, oh no, that's not right. So historically, the global sea level, let's go back 2,500 years. We're looking at the height of the sea over a long, long period of time. Until again, we're looking at the Industrial Revolution slot here, and then the sea level starts going up and up and up really fast. Up until 1990, it was increasing at about a half of an inch per decade. After that, it started tripling, 3 times faster now, and it's getting worse. So let's get a little closer to home. Here, the ocean is not a flat surface, so if we look at the west coast, the sea level in Puget Sound, up in Washington, is about 8 foot higher than it is down Southern California. There's a lot of reasons for that, currents and other things. But if we go down to the San Francisco Bay, South Bay is about 4 foot higher than Suisun Bay. And that's primarily because water is sloshing in and out with the tides every day, and it just builds up in the South Bay because it's more restricted. So let's see what's happening there. Here's 101. Here's Palo Alto. And here's the bay right up here, this blue, which you can't see very well. And if we just impart a 100-year storm surge, no sea level rise, just storm surge, what's going to happen to the bay? Boom. It's going to come out here, and it's going to flood all of this area. That's without sea level rise. Now, if we had a 50-centimeter sea level rise, that would come to the light blue down here. A 100-centimeter level sea level rise, it would come out to the yellow. And a 150-centimeter rise, sea level rise, which is what we're expecting, it will come all the way out to the red. So let's take a look at what's down in that area, South Bay. Little Silicon Valley stuff here. We've got, what do we have? We have NASA, we have Yahoo, Intuit, Dell, all these other things. Some of you have heard this survey before. I'm going to say it again, though. How many of you own an iPhone or an iPod or an iPad or a computer, Apple computer? Or Apple stock, you know. You can be feeling pretty comfortable because Cupertino is way out of the way, okay? Good. And that helps support my son, too, because he works for Apple. So I appreciate it. Keep those Apple products going. Sea level rise continuing here. Atolls. Atolls are islands that were formed from sinking mountains, and they're only about 6 foot above sea level, very low. Sometimes they get a little overcrowded. This is the Maldives. And unfortunately, we have sea level rising all over the earth. So these island nations are already being affected. They're being flooded out of their homes. So I just wanted to let you know that take a place like this, the Carteret Islands out in Micronesia. 2,000 people there. They've made arrangements to move their people onto the mainland of Papua New Guinea. Tuvalu has about 10,000 residents. They are already making moves to occupy the southern island of New Zealand. And Kiribati, or the way it's spelled is Kiribati, has 110,000 residents, and they are already set to move to some of the islands in Fiji. They can't occupy their homes now because it's already getting flooded. One more example, up here in Shishmaref, Alaska, these guys are on the coast. They're on the mainland. This is the Inupiaq Eskimos. But because the sea ice is disappearing, all the storm surge and the waves come in and destroy their villages. So they've got to move further back on land to protect what they have. So we're getting close here. You think that the refugee migration situation is bad now? Wait a few years, because we're going to have up to 140 million people moving around and getting out of their places because of sea level rise and other climate-related issues. So I want you to keep a close eye on this area down here. This is Florida. I'm going to show you what's happening with Florida. So here we go. 1, 2, 3. Keep your eye on it. Boom. That much is going to be disappeared. Here's Shanghai. This is about all of Shanghai, what you're seeing in that area. Shanghai, take a close look. Where are those people going to go? This is the stuff of wars, honestly. You know it. What time do we have? We're pretty close. So, the second half, in a little while, is going to be on all of the technological and political solutions that we have. And I hope people are interested in those. Right now, I think we're going to take some questions. And to start off, we have the very knowledgeable Dana Nutritelli, who's going to come up here. Dana is a world-renowned author. He and I taught this climate change course last fall for Renaissance. And Dana is the author of this book, Climatology versus Pseudoscience. Excellent book. It's on Amazon. And what is it? How much? So here, you plug it.
Go on Amazon and buy it.
So Dana knows a lot more about climatology than I do. I'm an ecologist. He's a climatologist. And he's a physicist. And he knows a lot more. So between the two of us, we don't know much. But, but we're going to try to answer some of your questions. So looks like we've got some time here. It's 1:15.
If you would raise your hands.
And I'm going to give you a microphone. Watch the cords.
How do we know which wildfires are contributed are caused by global warming and which aren't?
Good question. How do we know which fires are caused by global warming and which aren't? It's not really possible to say what specific event is caused by global warming or climate change, or what proportion of it is caused. We're getting better at predicting those events, and we're getting better at calculating how much contribution there is. But this is a long-term trend. This is a statistical process. So we can't tell specifically where something is going to happen and if it's going to be happening by climate change or not. But it's a process that is moving forward, and it's getting worse and worse and worse. And that's mostly what we can say.
Yeah, I mean, wildfires aren't caused by climate change. They're caused by some spark, like power line going down, for example, and then triggering the fire. But what climate change does is it makes things hotter and drier, and so there's more fuel available so that the wildfire then goes further and faster than it would otherwise have. So basically, on average, climate change makes wildfires more destructive than they would have otherwise been.
Tom?
Yes.
As China is prospering economically, they're leaving a bigger carbon footprint, as one of your graphs showed.
Yes.
And what is it that China's doing to lead the fight combating climate change?
Well, China is sort of it's ironic because, number one, they're buying our coal and they're burning it, putting more carbon dioxide in the atmosphere. But at the same time, they're leading in terms of producing solar photovoltaic cells. So they're eating our lunch economically by producing huge amounts of photocells. And hopefully their goal, and they've signed on to the Paris Climate Agreement, hopefully their goal is to wean themselves off of the coal and produce more from alternative energy sources.
Yeah, I mean, China's actually doing a lot. They get a higher percentage of their electricity from clean sources than the United States does. That includes hydroelectricity, but they have like a quarter of their electricity comes from hydroelectricity and other renewable sources. They have like over 100 electric car companies. They're doing a national carbon cap and trade system pretty soon, so they're actually kind of doing more politically than the United States is. And also, they have per person a much smaller carbon footprint than we do. They just have 4 times more people than we do. So it's important to bear in mind that they have more overall carbon emissions because they have more people.
Yes.
Well, I was pretty proud of myself because I had a hybrid, but now I'm told that the hybrid batteries themselves cause a lot of pollution. Is that true?
The concern with batteries is that you have to mine rare earth metals to create the batteries, so certainly, I mean, there's no perfect technology, and that is a concern. And there's also kind of concerns about, the people who have to do the mining. I mean, their health is at risk. So yeah, I mean, batteries aren't perfect, certainly. And the same thing goes for electric cars. They do more batteries than hybrids do, but they have a much smaller climate change footprint than burning gasoline does. And burning gasoline, you have to get the fossil fuels out of the ground too. So I mean, again, there's no perfect technology.
And just to manufacture a Tesla or some electric car emits a huge amount of carbon dioxide anyway. But anything that's produced, everything that you use, your shirt, your shoes, your glasses, everything that you use produce carbon dioxide in order to manufacture it. So the less we use and the more we recycle, the better it's going to be, so that it'll be less carbon dioxide going up into the atmosphere anyway. Yes?
You didn't mention ocean acidification.
Hold it a little further from your mouth.
Ocean acidification is a problem. I understand that's going to really cut down on the productivity of the ocean, and so many people depend on it as a food source.
Absolutely.
Would you comment on that?
So ocean acidification is really affecting a lot of areas. Probably 30% of the Great Barrier Reef was affected by a heat wave that came through there in 2016. But ocean acidification is basically carbon dioxide being absorbed into the ocean, and when it does that, it changes the chemistry of the water such that it removes these ions. Carbonic acid is produced, but it also removes ions that the organisms in the sea that build shells of calcium carbonate are not able to pull that calcium carbonate out of the water because the ions are missing. So the shelled organisms are suffering now because they either are not able to build any shells, or their shells are so weak that they break. So this is a huge issue for many of the things that we eat, oysters and clams and things like that. But it's primarily an issue with the acidity of the ocean and the inability of organisms to pull out the calcium carbonate that they need to build their shells. And also just the carbonic acid erodes the shells, so there's kind of two things that are happening at the same time.
The JSON and TOPEX satellites are pretty convincing, with an current increase of about 3.5 millimeters per year. If we make 100% error, a NOAA 100% error,
Hold on a little further out.
we'll go to 6-7 millimeters per year. But in the next 30 years, there's going to be 2.5 billion more people on this planet. Do you honestly think that we can solve the global warming problem without identifying the population issue?
No, absolutely. We need to incorporate the population into that formula. Absolutely.
Okay, over here, Tom.
Yes.
I would like you to comment on a news article that I saw just within the last hour. The lower house in Iowa passed a bill that said that a student could not be marked wrong on a science test if they had a religious objection to the content. I would call that aggressive ignorance. Perhaps you can find a better title, but if you could comment, I'd appreciate it.
Yeah, so that was in Ohio, not in Iowa, just to make sure we get the states right, that we should be scoring a little bit. So yeah, it's obviously not acceptable that scientifically incorrect answers should be accepted as correct because they are based on religious beliefs, because science and religion are two different things, and science is evidence-based, and so the answer should be based on evidence.
Yeah, thank you. So I'm aware that your second half is going to talk about solutions that are out there, but there are two large institutions that I'm wondering how much they have known and how much they are doing currently. One of them is the insurance industry, and the other one is military for the United States, which has massive resources like DARPA to do research with. Could you comment on whether or when or how much either of these big industries have taken note of this problem?
Yeah, so the insurance industry, the main thing the insurance industry is doing is either not offering insurance policies where there is high risk of things like wildfires, which are becoming more dangerous because
Or taking them away.
Or taking policies away, or just making them more expensive. And so that's a big problem for people who live in, on the coast where there's sea level rise, or in wildfire-prone areas, or these areas that are impacted by climate change extremes. And then there's also a reinsurance industry that kind of insures the insurers, and there are these companies like Munich Re and Swiss Re that put out all these good reports showing that all these extreme weather events are getting worse and worse and more expensive because they're kind of keeping their eye on the bottom line too.
Well, I'm going to cover the military in the second half. You want to add something? I mean, you kind of...
I mean, the military, there's a lot to say about the military, but I mean, the main thing is that the military has for a long time viewed climate change as a threat multiplier. A threat multiplier is there's already threats, and then or there's civil unrest, and then you get, for example, a drought that happens, and it impacts agriculture, and then just makes things that much worse, and it creates more concerns for civil unrest and factors like that. And then the military also has to worry about transporting fuel, because fuel, they need oil for all their infrastructure, and so oftentimes we get these convoys that are then targeted by opposition because they're trying to disrupt the fuel supply lines. And so the military is very concerned about that, and so they're trying to transition away from fossil fuels so they don't have to worry about their convoys being targeted. So they're doing a lot in terms of climate change.
Tom, thank you very much.
We're going to talk about alternative energy sources, especially without fossil fuels. So we've got lots of options, lots of options. We don't need to use coal, oil, and gas. We can use wind, solar, tidal. All of these have energy functions. Hydrogen fuel cells, ocean thermal energy conversion, where the top of the ocean is one temperature, the bottom is a different temperature. The movement of that creates energy. Hydroelectric, geothermal, there's lots of geothermal up by Lake County in California. Waves, currents, all of these are options to us. We have to use all of our tools in the toolbox. So this was stunning to me. I just want you to hear this. Every 2 minutes, the energy reaching the Earth from the sun is equivalent to the whole annual energy usage by humanity. We have an infinite supply of energy, free. Well, not quite free, but all we have to do is harness it. So we've got lots of options here. And the price of solar is dropping dramatically. This is 2014, and going down to 2018. And you can see how much it's dropping. It's continuing to drop every single year because of the production. So back a decade ago, the cost of a solar house facility was about $51,000. And just now, it's about $18,000. But if you take into account the 30% federal tax reduction, it's down to about $12,000, $13,000 for a solar photovoltaic system. About 6 kilowatt system. This is about average for homes. So the California mandate. And last year in May, the California Energy Commission ruled that all new homes after January 1st, 2020, must have solar to supply 100% of the energy in your home. Now there's some offsets that you could use, but this is really amazing advancement. So it's going to add about $9,500 to the cost, but you save almost $20,000 over the life of the system. So let's continue. So that's residential. So this is what we call grid scale for huge communities, regions. So these are trackers. These move 15 to 30 degrees with the tracking of the sun and to pick up the maximum incident radiation. So these are photovoltaic cells, and there's lots of them in Southern California. There's some in other places as well, all around the world. And China is doing huge amounts of photovoltaics, and they're eating our lunch with that. So here's another kind of solar power. I'm not sure how many people know about these. These are called heliostats, or solar power towers. And they're movable mirrors. Every single one of those dots up there is a mirror that's moving. And it's shooting light, reflected light, up to these towers, which are like 500 and 550 feet high. And they're filled with molten salts, liquid sodium, and the sunlight from all of these reflective mirrors heats the molten salts up. And so you don't need the sun to actually create energy, because the molten salts, or the molten sodium, holds the heat overnight. So you can still produce energy by using those molten salts to drive the turbines. So that's an amazing system. So we're getting away from having to have the sun out. So here's a 10 megawatt and a 20 megawatt solar plants in Seville, Spain. Here's a bigger one, 110 megawatts in near Tonopah, Nevada, and that can supply 24,000 to 96,000 homes for all of their energy needs. So we're making good progress. Most of these large grid scale operations are in Southern California. The gold ones are the photovoltaics, and the red ones are these solar power towers. And so this particular system is about 23,000 gigawatts, and that can supply electricity for 2.3 million homes. So we're gaining progress. So last year, in March of 2018, the utility grade or grid scale solar energy met 50% of California's total electrical power demand for the first time ever. Now, that's not to say that it's doing now. March is a time of year when we don't use as much electricity. So now we're down below that, but it's amazing that we were able to accomplish that that early. And of course, wind is another good option. It's coming up more and more. Wind provides 4.3% of the world's energy, and that's up from 1% in 2006. So dramatic growth in that area. So this is San Gorgonio Pass in Palm Springs, huge wind turbine farm. But you guys probably are more familiar with Altamont Pass as you go down Route 580 towards Livermore. That's a 576 megawatt facility and one of the oldest and largest wind turbine farms in the world. So we're making progress. Mr. Trump seems to have a problem with wind, and his problem is that he said it doesn't blow all the time. And therefore, it's a useless utility because it just stops sometimes. But the problem is we can't rely on one single issue, one single technology. We have to use wind and solar and all those other tools in our toolbox to accomplish what we need to accomplish. So here's an example in the North Sea. There's tremendous wind farms being developed in the North Sea. This is what you look at. We just came back from the North Sea not long ago. Huge, enormous wind farm. Let me give it a bigger scale on that. So here's the North Sea. Each one of those little red dots is another wind turbine farm out there in the North Sea. And a little closer up, if you can see this, so each one of those little propeller icons is a wind farm. And then the pink area up here are wind farm areas that are already being constructed. And the orange ones up here, if you can see it, are locations where they have permit applications in. So they're just going to fill up the North Sea with these wind farms. Tremendous availability of non-fossil fuel energy coming out. So as you probably know, we are a global leader. AB 32 in 2006, the Global Warming Solutions Act, established a program to reduce California's greenhouse gas emissions to 1990 levels by the year 2020. A decade later, 2016, the Senate Bill 32 was a sister bill of the Global Warming Solutions Act. It went further by reducing greenhouse gas emissions to 40% below 1990 levels by 2030. So we're making, and we are. So here's the emissions level in 1990, which is what the baseline is. That was 433 million metric tons of CO2. That's what California produced. But in 2016, the carbon emissions fell to 429 million metric tons. So therefore, California beat its own 2020 goals for cutting greenhouse gases a full 4 years before the target date of 2020. Fantastic accomplishment. Okay, let's talk about transportation. Transportation accounts for about 40% of the emissions, the carbon emissions in California, only about 30% in the US. That's because we have a lot more cars than the other places in the US. And globally, only 14%. So let's see what's happening with cars. So here's countries that are banning gas cars. They've announced in these years, 2017 to 2019, all of these countries, and they're planning to implement by these years somewhere between 2025 and 2050. So there's moves afoot. They're making these resolutions, and they're setting out to solve the transportation component of the emissions. In January 2018, California had a bill, AB 1745, to ban all new vehicles fueled by internal combustion engines by 2040. That did not pass. So we're still waiting to get something going in terms of banning internal combustion engines. So there's resolutions that have been passed in the United States, reducing vehicle CO2 emissions to 0 by 2040 to 2050 in California, Connecticut, Maryland, Massachusetts, New York, Oregon, Rhode Island. We need a lot more states to chip in, but that's what's happening so far. And if you want to solve the problem, you can have your sweetheart buy you a Tesla. Cindy, where are you? And if you don't want to do that, or your sweetheart doesn't want to do that, you can go to this site called What EV to Buy. So what electric vehicle do you want to buy? And this is what the site used to look like. It gives you how many miles per battery charge, and then it gives you also the cost of the vehicles, like Teslas, and are way out there. But you can either get a totally battery-driven electric vehicle, or a plug-in hybrid, or a fuel cell electric vehicle. So there's every single manufacturer of cars has electric vehicles of one sort or another. And they're getting better and better, and the better mileage every single year. So go to this site, What EV to Buy, if you're thinking of purchasing an electric-style vehicle, or a plug-in, or a hybrid. That will give you all of the information. This one was for 2018, but they're now on their website. They have for 2020, 21, and 22, all the vehicles that are coming up in the future. So look at it and buy your electric car. Not only is Tesla selling and making cars, they're also selling, and I'm not sure how many people probably know, you know this, they're making semi-trucks. And here's an example of one of them. Elon Musk has a nice unveiling of one of these on the web. And so because Elon likes speed, he likes speed, the cab here goes 0 to 60 in 5 seconds. With the trailer, it goes 0 to 60 in 20 seconds. Can you imagine that, going down the drag strip? So Tesla is not the only manufacturer of these big electric semis. There's all kinds of manufacturers out there, Daimler, Chrysler, Cummins, Nikola, or Walmart's making one. And they're using these for truck farms. So you have a truck farm here and a truck farm there, and go between point A and point B, plug it in, recharge it, go from point B to back to point A, recharge it. There's no use of fossil fuels there, at least in the engines. So they're all electric. And they're going autonomous. Now, this one here bothers me. I'm not sure what I would do if I saw that thing coming down the road at me. And it's autonomous. There's no driver. So, take your pick. The military's on it. Now we got to talk about the military. Military is building electric vehicles all over the place. They've been understanding what's happening in global climate change for decades, and they're sort of behind the radar. They're not really explaining or propagating what they're really doing. So they've got hybrid tanks. They've got people movers. They've got Bradley fighting vehicles. All these things, fuel trucks, and a lot of them are hybrids or pure electric. Now, the Bradley fighting vehicle, they're making one right now that's going to be purely electric, so that it's totally silent, and they're going to be able to sneak up on their enemies without making any noise. That's true. It's not out yet, but it's coming. So I wanted to show you a film clip from a movie called The Burden, which talks about what the military is doing to avoid using fossil fuels because it's so costly. I hope it works. You hear that?
I went to West Point. I studied a lot of highly skilled, advanced training. And when we got to Iraq, I was appalled at how little of it we actually employed. And just how much time was wasted on getting and protecting fuel.
We spend a lot of resources just moving fuel throughout the battlefield.
Everything they do relies on fuel.
The overdependence on fuels is affecting our environment.
the burden on the military will increase as they're forced to respond because they are the best first responders in the world.
One of the reasons why we're in the Persian Gulf is to maintain the stability of oil.
Every time the price goes up so sharply, it does economic damage. Oil we use puts money in the hands of some countries that are problems for us.
The consumption of oil is a national security issue.
Heat, lights, vehicles going up, fuel's the lifeblood, and without fuel, these guys be sitting ducks.
In the next 10 years, the Air Force Academy plans to generate all of their own electricity through renewable sources.
There's a huge potential for the armed forces to be an innovation pull in energy.
Americans by nature, it's in our DNA to look for the next frontier.
We can prevent future generations from having to be deployed for fossil fuel.
Using these technologies is providing great value to the taxpayers.
How much more powerful would it be if we had sources of energy that weren't geographically dependent?
We'd break free of oil. We'd say to the Middle East, see if you can drink that stuff. If we applied it in energy, we win the triple play of this American century. We improve the national security, create jobs, and we clean up the air.
It's not a cost, it's an investment.
The military is on it. They know what they're doing. They know what they need to do to solve these problems, and they know what to do to get away from fossil fuels. They're approaching a lot of different alternative energy sources, and I'm going to go over some more of those in a second. But ferry lines are basically the same thing as truck farms. Point A to point B, back and forth, plug them in at each end, no fossil fuels used. Today there's over 100 hybrid ships worldwide, and they're increasing all the time. So progress is being made. Locally, the Alcatraz ferry has been doing this for a long time. They have photoelectric cells on the top of Alcatraz itself, being able to plug in and fuel the ferries when they get there. And the ferries have actually photoelectric cells on their roof, as well as wind turbines up there as well. So the entire fleet now is all electric. And back to the military. This is the Navy's first hybrid drive warship, the USS Macon Island. It's a WASP-class amphibious assault ship, and they call it the Prius of the Navy. Launched in 2009, and then sort of rebuilt in 2011. And this one here is a hybrid guided missile destroyer, USS Truxtun. So they're doing all this with foresight. I mean, these things don't get built overnight. They've been working on this for decades, so they know what they're doing. Unfortunately, March 2018, President Trump's budget for 2019 canceled a program to install fuel-efficient hybrid electric drives in 34 destroyers. We're going in the wrong direction there, folks. And the ultimate test, the ultimate challenge is to build electric planes. Tough. But this particular air company, Harbor Air in Vancouver, British Columbia, plans to be the first all-electric airline. They go on 30 to 60-mile jaunts, bringing tourists and fishermen and other people up there. But they're experimenting with 350, 500, and 750 horsepower electric engines, which they can recharge at the other end, sort of like a ferry or a truck farm. And Airbus is moving in that direction. They have a competition out right now to see who can build the most efficient airplane, all right, electric airplane. So we're moving there. Air traffic, air transportation only accounts for about 2 to 3% of our global carbon dioxide emissions, but every bit counts. We'll be way ahead if we start to be able to develop electric airplanes. So, next, in terms of solutions, geoengineering solutions to lower the concentration of atmospheric CO2. So here's the best one of all, a tree. It's the most efficient one we've got. And the more trees you plant, the better we're going to be in terms of taking carbon dioxide out of the air. And we also have what's called direct air capture. We have to remove this stuff, we have to back it out, reverse the process of emitting CO2 and put them back into the smokestacks, not literally. But this process of taking carbon dioxide out of the atmosphere, remember I mentioned carbon dioxide is going to last for 500 to 1,000 or maybe longer years. We need to get that stuff out. So here's an example. This company is called Global Thermostat, and they have 2 different locations, Menlo Park and Huntsville, Alabama, and they're using solids to take out the carbon dioxide. These are all prototype. There's nothing I mean, they're functional, but they're all in prototype mode. CO2 capture from the air was first developed by Nazi scientists who used liquid sorbents to remove accumulations of CO2 in submarines. So this is kind of where it all started. But these guys are making progress. Here's another company, Carbon Engineering in Canada, and they're using liquids instead of solids. And here's a prototype arrangement here. The problem with these are that these big fans have to blow the air by this liquid material, and it just takes a huge amount of energy. So we don't want to be creating carbon dioxide in order to be taking it out. But as we develop more and more of the alternative energy sources, wind, solar, all these other sources, hydroelectric, we could possibly, run all of these on alternative energy sources and then be pulling that carbon dioxide out of the atmosphere. It's a long way down the road, but we're hoping that we can do something like this. We need to pull carbon dioxide out of the atmosphere. And here's 7 different companies that are working on this direct air capture prototype facilities. New York City, Wisconsin, Switzerland, Italy, Canada, Netherlands. So they're all out there trying their best to make this happen. 50 years ago, Apollo 11, one small step for man. This program has a soft spot in my heart, partly because one of my cousins was an astronaut in the Apollo program. You may have heard the name Gene Cernan, but he was the last man to walk on the moon. But more so, I was impressed with what JFK had to say about the moon program. We choose to go to the moon. We choose to do this not because it's easy, but because it's hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we are willing to accept, one we are unwilling to postpone, and one which we intend to win. We are there now with climate change. We can do this, and we need to do this. So the tools to do the moonshot did not exist at that time. It took NASA 8 years and 400,000 people to literally invent the rocket, the spaceship that could land on the moon, the spacesuits, etc. All of that had to be invented from scratch. However, today we're in a different situation. An iPhone has more processing power than every NASA computer excuse me, in existence in the early 1960s. We have the technology to do this. We have the computing power. We have the will. We have the scientific know-how. So we need to do it. What we don't have is the political will. Okay, remember this guy? James Hansen? Congress, 1988. Who's this guy? George H.W. Bush. Also in 1988, George W. Bush was on his presidential campaign, and his slogan was, "We'll fix the global warming effect with the White House effect." So he was claiming he's going to fix global warming, and if we started in 1988, we would be there. But unfortunately, that didn't happen. He got into power. He served from 1989 to 1993. He was an oil man. He owned his own oil company as well. And unfortunately, once he got into power, once he was inaugurated, that promise sort of fell away. And at the same time, Exxon and several other oil companies, they knew exactly what these greenhouse warming gases were, and they knew what they were doing, and they knew that we were going to be increasing the temperature of the Earth. They kept it from the public, they kept it to themselves, and only recently did they admit that they had those back in the 70s. So we need to We need to solve this problem, and at this point in time, 1988, which we talked about before, this was probably the time when global warming and climate change became political, because the oil companies were controlling this resource, and they didn't want to lose the profits, and so they said nothing for decades and decades. So let's take a look at what's happening politically. This is a figure from the Yale Center for Climate Change Communication, Director Anthony Weiserowitz, and this is a majority of registered voters, what they think about global warming and it's caused by human activities. So the top line is a line, this is from 2008 to 2018, pretty much the last decade. The blue line is representing liberal Democrats. The gray line below that is moderate to conservative Democrats. The pink line is liberal to moderate Republicans, and the red line is conservative Republicans. So over time, hasn't changed much, but you can see it's increasing. More and more people are believing that, and the black line is the average of all of them. So right now, 59% of all the registered voters that they were polling believe that climate change is real, global warming is real, and mostly caused by humans. What are we going to do with that? The top one, 84% of the liberal Democrats believe that it's, human activities. 26% of the conservative Republicans believe that, but we've got a large gap between those. And back in 2016, in the election, climate change was like the 15th or 20th item on people's concern list of concerns. Right now, it's in the top 3. And that's primarily because people are getting hit with this climate change stuff. Their houses are burning down, their houses are getting flooded. They're feeling the effects of climate change. So they're more inclined to voice their opinion and try to do something about it, maybe vote for candidates who are really going to try to solve the problem. So going back a little bit to 2015, President Obama was a leader. He brought 194 countries together to formulate the Paris Climate Accord, or Climate Agreement. There were 2 countries that didn't sign on initially. It was Syria, because they were in the midst of a war, and Nicaragua, because Nicaragua didn't think we were doing enough with the Paris Agreement. So a year later, the Paris Climate Accord was ratified, and both Syria and Nicaragua joined. Okay, so we've got 196 countries, and unfortunately, the very next year, 2017, Trump administration is pulling out of the Paris Accord. We need a global leader to bring these countries together again. There is not one right now. We need a global leader that's going to work hard to solve this climate crisis that we're in. November 4th, last week, was the first day that Trump was able to officially, legally, start pulling out of the climate accord. He filed the papers for that, and 1 year from November 4th, in 2020, we will be out of the climate accord, officially. I mean, it doesn't make much difference because we're not doing anything in the United States anyway to support it. However, here's some politicians discussing global warming. That's kind of depressing. However, the good news is that over 6,000 companies in 7,000 cities in 133 countries are implementing the greenhouse gas emissions reduction protocols despite what we're doing and following the Paris Agreement. So there's lots of good news out here. Many of our states are doing it, many of our cities are doing it, many of our corporations are doing it. So yay for them. So where do we go from here? Well, what's the real bottom line? Again, we need to use all the tools in our toolbox. We need to engage the federal government, the states, the cities, the corporations, the NGOs, the individuals. We need to eliminate the use of fossil fuels. We need to reduce CO2 emissions in all ways possible, remove CO2 from the atmosphere, direct air capture, increase energy efficiency in all ways, enact regulations to reduce carbon emissions, put a price on carbon, Support research and development, provide subsidies for innovative ideas, and act to protect our future generations, our kids, and their kids, and on and on. Okay, here's the biggest graph of the whole afternoon. You put on your thinking caps, and I'm going to walk you through this. This is 1980 up to 2100. Here's James Hansen right here. 1988 gave us the warning. This black line is the concentration of CO2, it's the emissions of CO2 increasing. So here's the year 2000. If we started in the year 2000 to start reducing our emissions, this is a model run, we would follow this yellow line and it would bring us down to where we need to be in 2100. We would only have to have reduced our emissions by 2% per year. We didn't do that. Now we're up here at 2019, almost 2020. We still haven't done it. So starting in 2019, we would have had to start reducing our emissions by 5% per year. That's a good amount, a tough amount. But since we haven't done that, there's 10 dots here, would bring us over to 2030. We don't have that long. 2030, we would have to reduce our emissions by 9% per year. That's tough. That's really tough. We need to start immediately starting to reduce our emissions and doing everything possible to pull CO2 out of the air and to stop it from existing in the first place. So that's the main dictate, is that we need to work quickly. I mean, we can't start in 2030. We need to be well along the way by 2030. So California, and at the federal level, there's a bill called the Energy Innovation and Carbon Dividend Act of 2019. We've got 57 Democrats co-sponsoring and 1 Republican. But basically, this is the one that's moved the fastest, or moved the furthest along the process. They're in committees now discussing it. There's 7 different carbon pricing bills in the legislature. Not one of them has been voted on. And the Citizens Climate Lobby, represented in the back with Edith Thatcher, is representing Citizens Climate Lobby here. They are supporting that bill. Okay, it's called the Carbon Fee and Dividend Bill. Citizens Climate Lobby has over 100,000 people worldwide. Jim Hansen is one of them. And Catherine Hayhoe, who just gave a talk at Davis, one of the world's leading climatologists. The Citizens Climate Lobby sent 800 CCL members to Congress last week. No, it was this week, wasn't it? Yes. And they had 472 appointments with legislators or their staff to try to move this bill forward. So before you leave, I invite you to take a look in the back table. There's Citizens Climate Lobby information there. And think about signing up. So kind of winding it up, again, we need to use all the tools in our toolbox, everything: electric planes, tanks, cars, direct air capture, grid scale battery storage, which we haven't talked about, but is coming onto the landscape here really soon. I mean, there's battery power grid scale now, but it's just in its infancy. And legislation, put a price on carbon. One of the other things we need to deal with is the fuel industry subsidies for 191 countries. Coal and oil gets 85% of the subsidies. In 2017, there was $5.2 trillion, that's with a T, trillion dollars in coal and oil subsidies, oil, coal, and gas. 6.5% of global GDP. The largest subsidies are being given by China, 1.4 trillion. Largest subsidies second largest subsidies are for the US, 650 billion. India, third. And so how are we going to change this? If we use just a tiny, small fraction of the subsidy money and put it towards alternative energy, we could be making huge progress. So how are we going to make a change? Make no mistake, public opinion is everything. I've talked to many legislators and their staffs, and they all tell me the same thing. every piece of information they get, whether it be a tweet, an email, a postcard, anything, phone call, they register that opinion. And they believe that that piece of information represents somewhere between 100 and 1,000 other individuals who would never think of contacting their members of Congress. That's powerful. People out there demonstrating in the streets. Power in numbers, power in speaking your mind. So this is a grassroots group that my wife Cindy and I started a couple of years ago. And what we do is we write postcards. Last year we wrote 3,500 postcards. And I made a little calculation here, 3,500 times 1,000, that's 3.5 million pieces of information that were received by members of Congress, either in the state or the federal government, to thank them for things that they're doing right or abuse them for things they're doing wrong. But you can see these people are writing postcards. Most of them are. What's this guy over here doing? I'm not quite sure. Anyway, most of them are writing postcards. And we do. This was just this last week we were writing postcards. So start or join a grassroots group, and your opinion is worth a lot. Every single one of you. Think about this. 300 people in the room times 1,000 is the same thing. Also, personal responsibilities. Each one of you can do things at your home or in your lifestyle that change the carbon dioxide that you're emitting. I have flyers in the back. They're color green like this. Yep. And they have energy product consumption. They have water and vegetation, transportation, foods, lots of things. Plant trees, eliminate single-use items. Everything you buy, everything you use has a carbon footprint. So on the back of that sheet is the reasons why you should be doing each one of these things as well. And it's listed on my website, tomsokonic.net, if you lose it. So please pick up a handout in the back. And most critical actions, for those a little off here, educate yourself and your tribe meaning the people you hang out with, the people that do the same things that you do. So educate your friends, educate your frenemies. Communicate with your members of Congress. That's what we were just talking about. And if you're uncertain about it, talk to us and we can help you to formulate a grassroots group. And the most important thing of all, vote in all local, state, and national elections. For those who will try to work hard to solve this crisis. So, I'm going to ask a question. If there were an initiative on climate change, how many people do you think here would be interested in joining that initiative? Anybody? Oh, there's only about 200 out of the 300. Okay. That's good news. Make a difference out there. So we'll get back to you on that. And I think at this point, we're going to just jump back into the questions. Thank you.
All those wind farms in the North Sea,
yes.
In the ocean.
Yep.
What kind of protections for sea life is there, for marine life?
I don't think there's much. I mean, they're just anchored there. I don't think there's much that's happening. All the movement is up above. Louder. So clearly there was some disruption when they put them in, but I'm not aware of any major disruptions that I've heard of after their work.
I mean, the blades are above the ocean surface, so there's not much disruption to the marine life.
Have the electrical conduits going back in there.
How about the chemical reaction, whatever it's covering the towers and all that?
The chemical reaction of what's covering the towers. I think they're probably pretty, it might be stainless steel or plastic or something, I'm not sure. Next. Yes, Jack.
Well, you mentioned a couple of the alternative energy sites. One of them is being Ivanpah,
yes.
Which is really environmentally destructive.
In what way?
And the other being Altamont, which also environmentally destructive to the birds. We've lost a lot of migrating birds because of Altamont. Ivanpah, of course, they just scrape the desert clean, scrape all the wildlife burrows and the tortoises off. So what do we do to mitigate those things? We can't just be building all these things and say the desert and, oh, well, the desert is worth something. These people don't believe it's worth anything. The problem is it is worth something. It's part of our ecology. We can't get rid of that.
Completely agree. And there are disruptions that occur when they're putting these in. It's a trade-off. Everything's a trade-off. But in terms of the Altamont Pass, there's studies going on in terms of how much distance they should have between the turbines, and even painting the blades different colors and different stripes to make the blades more visible to birds, the predator birds. So they're trying. They've been working on this for about 10 years, and there's other wind farm experiments going on to eliminate the blades altogether, but just to have these spiral wind blades that go around like this instead of around like this. So they're working on the technology. They know that there's some disruption involved. They have to find a way that meets both of those criteria.
It's also important to bear in mind, yes, we're minimizing that, but it's important to bear in mind we have to get our energy from somewhere, and oil spills and blowing up mountains to get coal is much more disruptive than solar installation in one location.
I recently read an article about a fellow in England named Trevor Jackson, and he claims to have developed an air aluminum or aluminum air battery, which apparently could take a car like 1,500 miles using some electrolyte. Are you aware of that, and is it real?
Yeah, I haven't heard of that particular technology. I mean, I'm always skeptical. There's always new stories of this new technology. I mean, until it kind of comes to market and proves that it can be done affordably and cost effectively, then I'd remain skeptical. But if they can make that happen, that's great. Until it happens, we'll see what we believe in.
Right here.
You haven't mentioned nuclear. Are there no safe options under development?
Nuclear is still, in my opinion, nuclear is still not viable simply because, number one, you have the waste that needs to be stored someplace, and that waste is often radioactive for 250,000 years. So we need to find a really solid place to store that or isolate it. And second of all, the risk of it failing, either through a terrorist operation or a natural event like happened in Fukushima, is still a risk. And so for those two reasons, I feel really uncertain about supporting nuclear. We have some other.
Yeah, I mean, we're saying that groups are working on developing like next generation nuclear using thorium and like they reuse the fuel rods, and so it has less of a waste concern. So yeah, it's something we're working on developing. It's just we're not there yet.
Next.
I had a question on fuel cells. I didn't see those mentioned up there, hydrogen fuel cells. It seems like 10 or 15 years ago, there were experiments with some building-sized fuel cells that could be set up burning hydrogen for electricity to power plants and things like that, like sewer treatment plants. Has there been any progress on that?
Yeah, there's been some progress. So building-sized fuel cells, and also I think for like a large ship transportation, fuel cells are kind of promising. So it's kind of progressing slowly. Like for a while there was kind of some focus on trying to get fuel cells for passenger cars, and that kind of just got bypassed by electric cars because it's more efficient to use the electricity just to charge the battery directly than to use the electricity to make hydrogen in the fuel cell. But so it's better for large-scale applications like buildings or like big ships. So it's progressing. It hasn't been deployed very much yet.
This will be our last question. We promised we would get you out. This is our last question. And Tom, they will stay around if you'd like to ask questions afterwards with them.
Is there a market for the old Prius batteries? We heard that there's still a lot of life left in batteries when they can no longer power the cars, and they can be used in conjunction with solar.
Yeah, I know there's been talk of using old EV batteries for storage for electricity from the grid. I don't know if anybody's doing it yet, but it's kind of thing that we're looking into. Like once there are a lot of old Prius batteries, then there will be enough scale so that can be like a viable option. But I haven't heard of anybody doing it yet.
Thank you so much. And Tom, to the emergency fund for the students at Sac State in Tom's name. So Tom, thank you.
Yeah, so if anybody else wants to ask questions, feel free to come up and talk to us.